So I'm Mateo.
I'm Matthew.
I'm Kyle.
I'm Ryan.
And today we'll be showing you the excitation-contraction coupling and sliding filament mechanism of contraction.
We have an electrical impulse that enters the myelinated axon motor neuron and travels until it hits the terminal of the muscle fiber. That activates the myofibril, which contains two Z discs and an H zone in between, which can also contains I bands that are light and dark A bands. In between two I bands is the sarcomere, which contains the myosin and the actin, which also has the M line in between.
Electrical impulses from the muscle go through the axon terminal of the motor neuron and hits the ACH vesicle that releases ACH. After it releases ACH, it goes down into the synaptic cleft and hits the ACH receptor that sits on the motor plate. That releases calcium through the T-tubule and it goes to the myofibrillar.
So when calcium reaches inside the myofibril, what happens is that it connects to the troponins that are out here so that the trypomyosin can relax, opening up the actin binding sites. Right here, the myosin head is in a cocked position with ADP and an inorganic phosphate. Later, the myosin head connects to the actin binding sites, which work the actin in a rowing motion towards the M line. Then when ATP comes in, it relaxes the myosin head so it can detach from the cross bridge. And then finally, when the ATP breaks down in ATP hydrolysis, the ADP and the inorganic phosphate form and make the myosin head in its cocked position.